welcome public inventors. This is Rob. I'm giving into a little bit of childishness here. I have a result that I'm pretty excited about that I wanted to show you guys. As you may know, I mentioned that my latest Gluss Pusher is not very reliable and I want to make it a closed loop system. And I was trying to figure out how to do that inexpensively. So I think I've come up with a fairly elegant solution. What I've done, which I'll show you in a minute, is in the back side of the tube here, which I've had to wrap in construction paper to close it, I've included a white light LED and a photocell. And the photocell is protected by a tiny little black tube that I cut from a carbon fiber arrow that goes about an inch in there so that the LED shines down the shaft here and there. And on my push rod, I've just taped a little piece of white cardboard to make it reflective. And although I have not done this with an Arduino yet, as you can see as I move the push rod, it pretty clearly changes the voltage in a way that should be within the resolution of the Arduino to read pretty effectively. So let's see, it's going from about 2.5 volts to about 3.5 volts in the range that I can support, maybe 2 volts to 3.5 volts, and that's pretty reasonable. I'm using a voltage divider on this Arduino board. Basically, it's exactly the circuit that comes with the Arduino Development Experimenters Kit, and the only smarts went into taping together the LED and the little photocell in the end. I think this could be a really good way to handle the closed loop stuff. It might actually be a good way to make linear position sensors in general. Obviously, it's going to require calibration. However, in our case, we're making a stepper motor, which has fixed gradation, so it can auto-calibrate really easily. So it should be the case that since we're using an Arduino and paying for a microcontroller price anyway, this may be a very elegant solution and much better than a physical potentiometer, which wears out over time. It should be fairly reliable if you recalibrate it automatically. It's also cheap because it's about $1 for a photocell and about 10 cents for the LED. And of course, you need some resistors to build the rest of the circuit. Anyway, I'm going to try to read that with the Arduino and tie it into the motor circuit that I showed in the last video.